Hi, my name is Mateusz. I'm a software engineer at the Oasis Protocol Foundation. And today I'm going to talk about the hot topics we're currently tackling at the Oasis. Before we start, I just wanted to ask you, how many of you program in Solidity? Yeah, hands up. Okay, cool. And what about in Rust? Single one. Okay, not bad. Yes. Okay, awesome. Let's talk about confidential blockchain and why are we doing blockchain in the first place. So it's a distributed network of nodes, right? There is no centralized authority, no censorship, which is great. Computation is very robust. It's completely redundant. So is the storage. Every node stores everything and knows about everything that's going on chain. But there are also some caveats, right? Because it's a complete redundancy. The storage and the computation is really expensive overall. We have a blockchain which consists of blocks, right? So despite having an instant finality, for example, at Oasis network, you still have to wait for a block time in the worst case. So this is 6 seconds. In our case, so the expected time is what, 3 seconds, which may be too much for some applications. And finally, at least in Ethereum, the world state tribe is completely public. It's transparent to everyone. Transactions are public. So at Oasis, this was years ago, we developed a confidential EVM compatible blockchain. We call it Oasis Sapphire. So what do you get? You get an encrypted contract state. This means that everyone will be able to access any contract, but it will not be able to see what's inside the contract state. Then you have transactions. All transactions can be end-to-end encrypted. So the whole ledger of transactions will contain, normal transactions. Everyone will see those transactions, but the content, the call data of those transactions will be encrypted. You will still see the from, the to address, the gas information, but not the call data itself. We are EVM compatible, so even though this sounds awesome to have encrypted contract state, we are still trying to be EVM compatible. Apart from that, it gets the rejectables, for example, it gives you the contract storage state, which cannot work in our chain for us. How do we do it? Well, we run the complete Sapphire EVM inside the trusted execution environment. Intel SGX, to be more precise. So this is how we preserve the privacy. So every node operator who wants to be encrypted needs to have SGX, and he cannot, he has no idea what exactly is going on inside the trusted enclave. Right, so on the client side, if you want to have encrypted transactions, you need to use our wrapper for either TypeScript or Python. And then all the queries and transactions will be end-to-end encrypted. So on top of that, we also extended the functionality of Solidity. We offer Sapphire.solve library, and you can do some really exciting stuff with it. You can have a random number generator, which runs completely on-chain. And then since you have random numbers, you can also generate and derive new key pairs. And once you have key pairs, you can sign messages, you can encrypt, decrypt everything on-chain, which is really, really cool. And for those of you who may be familiar with signing with Ethereum, so this is a mechanism developed a year ago, basically for users who have MetaMask wallet and they want to use some Web2 applications, and without having email address and so on, they can just log in with their Ethereum wallet. Well, now we support CV parser on-chain, so you can now have a complete Web3 application running completely on-chain. Even the message, the CV login message, can be parsed on-chain. For cross-chain communication, we have ROFL. It's an abbreviation for Oasis privacy layer. So if you have an app running in some other chain, and you want to have some portion of that app running on a confidential chain for managing confidential data or some logins, whatever, then Opal uses seller bridge under the hood. So we prepared some basic building blocks for that. And now, to illustrate this, so basically you import our Sapphire song library. To generate random number, simply call sapphire.random bytes, and this will give you, in this case, 30 random bytes. And then, if you want to return the favorite number of your user, or if you want a lottery, for example, or if he got a swag or not, you just do the model operation and extract the number. Or if you want to generate a key pair, you call the generate signing key pair function, providing the seed. We also support the SEC256 as well as the ED5519 encryption scheme. Then you can encrypt and decrypt on-chain. These are all precompiled, so they're very cheap. Then you can sign a message and verify if the signature is correct. And there's also one cool thing you can do with it. You can also generate an Ethereum transaction on-chain and sign it on-chain. And then you can sign it with some account which is funded. So basically, you get the gasless transactions for your users very, very easy. So those of you who follow the account abstraction debates in the Ethereum world, well, this thing is much easier. It's a straightforward implementation of the simple signing the transaction, and it already works. And finally, I mentioned Siri before. So this is the nice pop-up MetaMask shows you if you want to log into some app. And how we do it? Well, you store the domain where your dApp lives inside the smart contract, and basically the user then calls the login function of our contract. Our parser checks whether the login credentials match the signature of the message, and then it obtains the bearer token, and with that bearer token, you can then proceed doing some confidential queries to your smart contract. And this, in this code here, this auth message sender helper will extract the original, the proper message sender from the bearer token the user is providing, which then tries to communicate with the smart contract. Okay, but this is all blockchain, this is all on-chain, and this is so 2023. This is what we did in the past. Sapphire is now, I think, 2 years old. It's running in production for a year now on mainnet. What we did this year and what we're still working on is, like, wouldn't it be cool if we use this trusted execution environment to execute transactions, to do the computation off-chain? Since it's running inside a trusted execution enclave, we can still trust it, although it's not running strictly on-chain. The positive points on this are, it's local, it's much, much cheaper because if you consider AI or gaming or whatever, it needs to be fast and cheap. And even the NVIDIA H100s support the trusted enclaves. So you can basically perform computation off-chain and just use the blockchain part for signaling, right? So to manage your off-chain application, to manage the authorization, and who can run computation to build any users that they want to use your platform for this. So we basically combined both worlds, like the performance from the off-chain world and the trust from the on-chain blockchain. And we call this ROFL. So no pun intended, it's just a runtime off-chain logic, okay? And as I mentioned, this is ideal for the AI if you want to have machine learning, which is confidential, which you can actually prove that your model was trained on a specific set because it was trained inside the TEE, so you can actually trust it. This is cool for gaming because the block waiting time is, as I mentioned, like 3 seconds expected on Oasis. And here you can just open channel in parallel and have an instant response. Anyone familiar with DEX, the decentralized exchanges, they always need some oracles behind the scenes, to fetch prices from other chains and synchronize the price quotes. Now you can actually develop an oracle inside ROFL, and you can trust it because it runs inside the trusted enclave. So it won't be any censorship involved because you can actually see the code and verify that the ROFL is really running what it's claiming to run. The mandatory sketch looks like this. So each Oasis node can run ROFL app inside the TEE. There's a light client in the attestation because it tries to ensure that the ROFL really connects to the chain you want it to connect, so you don't connect to any third-party chain that will spoof any of your confidential data. It communicates with Sapphire, so any storage you want to have, for example, storing your private key to access your AI, to decrypt your AI training set, is stored inside some smart contract on Sapphire, for example. But in parallel, you can also open HTTPS connections freely. This is something you cannot do inside a smart contract, right? You cannot just connect to Amazon, whatever, inside Solidity because it's a closed environment. And here you can use ROFL to open HTTPS connections at your own choice. And then do some computation and maybe store it on-chain or just fetch some data from on-chain to process it. Okay, now I made a small example of this. So we're going to build an oracle that will fetch prices from from Binance and store them on-chain, like every block. So this is the Solidity part of the code. Basically, what you do in Solidity is you store this ROFL app ID. This is something similar to what you have in the Chrome Store or Play. So every app has its own ID. Even though it's upgraded to a newer version, the app ID remains the same. So here, we kind of prohibit any other apps accessing this smart contract apart from this app we defined in the constructor, I think. Yeah, here it is. So we store the ROFL app ID in the constructor, and then this modifier, only auth app, makes sure that the whichever app is contacting this smart contract, it checks whether it matches the stored ROFL app ID that is allowed to store the price quotes. And the submit observation is the main function which basically just pushes the observation of the price quote. The price quote is here, so it's a value and it's a block when this price quote was taken. Okay. Now the fun part. This is the Rust code, and this is the code that runs inside ROFL and that does actual fetching of the price quotes. So here it connects to Binance. It checks the rose USDT value. It's a JSON format, so you need to decode it. And then, because, well, Ethereum doesn't know anything about floating point operations, we multiply it by 1 million and have an integer at the end of the day. And then we store this price by calling our smart contract, the observation function, and passing this data. And then we set the gas fee, and we sign and submit a transaction using the built-in signer of the ROFL. So this is done all seamlessly, and it connects to the Sapphire, the one who you configured your ROFL to attest with. So Sapphire in the case. Right, and then there is some boilerplate. For ROFL, you need to define the trust root. This is the height of the block you trust, its hash. The runtime ID, so this is the runtime, this is the ID of Sapphire, and the chain context, the hash of the Genesis block, basically. The app ID is also stored inside ROFL, and this is basically it. So it runs itself, and then on every incoming block, it runs this run Oracle function, so fetching price quotes from Binance and storing them on-chain. Okay, so for hackathoners here, I'd like to point out some resources. So docs.oasis.io is your holy Bible for everything. And then we have the Deb Sapphire subpage, which is all about Sapphire. ROFL subpage for ROFL. If you are building a cross-chain app, then Opal, that Opal is the toolkit you want to use. We have wonderful playground.oasis.io website, which collects all the previous hackathon projects and any other cool projects, demo projects, educational material running on-chain on Oasis. And finally, I prepared the cheat sheet. You can follow this link or scan the QR code. So it's a A4 plain paper, and there are a bunch of links to documentation mentioned here, the wallet, the Explorer, and every other tool you need to lift off. Okay, so I have a minute, right? Yeah. So let me just show you quickly that this actually works. So I'm running Sapphire LocalNet here on my computer currently, and it's running in a simulated mode. That means that you don't need SGX to run it. And here, what I did was, there are a few accounts which are funded, and I also compiled the ROFL I just presented to you, so it's matching price fees. And what it does is, so we have, yeah, the ROFL is up and running. And if we now check the smart contract part, we should see that the last observed price is 67,000, not dollars, but millions of dollars. So that's like 6.7 cents per Lowe's token, okay? And the block number was 4749. This is running locally, so every second there's a new block mined on my computer. And if I repeat this, the block number increases, and the price, slightly changes every night. Okay, so point being, you can develop ROFL apps now. You can also deploy it on testnet, but you can also deploy just locally and to test it out, to debug it, and this is already for hackathons. All right. Any questions? Yes, go ahead.
So the ROFL itself runs based on hooks, right? And one of those hooks is actually on runtime block. Is that the only available hook?
I will need to check this actually, so I'm not sure. But if you're referring to the messaging, there is no way to directly communicate with ROFL from the chain yet. So you need to rely basically on reading the contract state if something changes, and then reacting to that. So if you want to send a message directly to the ROFL, either you need to open a separate, HTTPS connection to some port IP somewhere outside, or you just, regularly call the contract state if there is a message waiting for you. You need to implement this by yourself, an array of messages, and then get last message.
So there's no limit to how much CPU is actually being used inside the ROFL app? No. Okay. So you can keep a connection open, like a WebSocket even.
Yes. So the ROFL, keep in mind that ROFL runs inside Oasis node. So you must run the Oasis node with Sapphire, and then besides you initialize another ROFL, and then those two communicate with each other. So that's why you can do this pulse to the chain very cheaply, because you don't communicate to actually everyone around. You just communicate to your neighbor process on the same physical machine.
Okay. Another question, sorry. So once you deploy the ROFL, there's only one instance running, or there's going to be automatically many instances that's actually going to be running. Like how do we decide once we register the ROFL, how many actually run at a time?
So you have to run, first when you register a ROFL app, you define this policy file, this policy YAML file. Inside, you define how many instances there are allowed, and you can also whitelist the nodes. So each node has its unique identity, and you can define the public key, which nodes are allowed to run your ROFL if you want just to limit to a couple of nodes. But at the end of the day, yes, if it's open to everyone, then everyone can load your ROFL and run it. And there's no limit, basically, because the only way they communicate is via blockchain anyway. So there's no reason why not to run. So it's a complete distributed network of ROFLs that matter, running in parallel with the blockchain.
Oh, okay. So with pertaining to gas fees, if each of these instances they start submitting data.
Each node has its own key pair, which it runs ROFL, from. So you need to fund
every single instance.
Yes. And if you're using this built-in mechanism to submit queries, you can always, store another key pair inside ROFL if you want, and then use that for signing transactions. But the trusted way of currency, how it's done, is basically you take the node's key and the node funds your transactions. Yeah.
Thank you.
Okay. Yeah.
Let's say we're storing some data here, right? With basket, can we make sure that only couple of wallets can have access to, and if will be encrypted for
So the Sapphire blockchain is fully encrypted. So whatever you store to the smart contract there will be encrypted. So if you store a wallet key inside the smart contract, that's perfectly fine. And then you need to build your own, smart contract logic in Solidity. Who can access that key? Whose key is that?
we can program that.
Yes, yes. And so every smart contract should have some kind of the access control list. Yeah. And it's much more important here because we have a confidential state, and you need to make sure that only specific users can also run queries, because you have this gas cost attack. Because you can assume what's the internal state of the contract if there are some if statements inside your business logic of the smart contract that depends on the what's the balance of something. Then take this path. What's the balance? They take the other path. Then someone could forge the message sender and try to behave like simulate Paul if I were someone else, and then extract some important data from the smart contracts. So that's why we prohibit doing simulated calls if they are unsigned. If the queries are unsigned, then the message sender will always be zero, regardless of whatever you define in the call. Otherwise, yeah, if you sign the call or sign the transaction, that means that you are you, and then the message sender is valid, and yeah, you do the rest of the business logic. Okay. I have one more question.
Okay.
Quick one, yes.
So what is the suitable use case for today that we can clearly see consider of the node fees and other stuff like performance stuff?
Yes. I mean, you can do ROFL. You can start with the example I showed, maybe, and then do some fetch price quotes. But yeah, from the 2023 story, like the Sapphire story, you can do the whole myriad, of awesome apps you can do inside the confidential smart contract. Yeah, so gasless transaction is just one thing. You can do cross-chain ROFL, you can log in with CUBI. Yeah, so wallet, your colleague mentioned, like on-chain wallet, for example. Yeah. Okay, thank you. Thank you.